Everything I've been hearing about robots over the past few months, new models being released, they're being used in factories, one company's trying to put them in homes, has made me pretty much accept my fate. For as long as I can remember, humanoid robots looked cool, but were pretty much useless outside of demonstrations. But that is starting to change. 2026 is the year where robots actually start entering the real world. Companies like Tesla and Agility Robotics are starting up factory lines to produce thousands of these things. Billion-dollar AI models are being trained specifically to power them. It seems like right now we are at the beginning of a major shift in technology. And that might sound familiar, because learning about robotics today might feel a lot like learning about ChatGPT in 2021, right before it was everywhere. There's this pattern that shows up every time a new world-changing product is released. The developers spend years working on it in relative silence, and then all of a sudden, everyone finds out about it at the same time. This leads to a curve that Marcus Brownlee has talked about, where when a new product is released, it has very fast and dramatic improvements at the beginning of its adoption. It's like when you compare ChatGPT today to the first LLM ever built, they look like night and day. And right now, I believe that robots, when I'm talking about robots in this video, I'm talking about humanoid robots specifically, are just now entering the beginning of that curve. Now you might be saying, robots are just toys. They can't do anything useful. And 5 years ago, you'd be right. But look away from a developing area in tech for a few years, and you might return to discover that it's basically unrecognizable. Rewind to 2019. Reporters were saying that it would be the year of legged robots, only to find out that Asimo, one of the most famous humanoid robots in the world, was being killed off. There were two main things holding Asimo and other robots at the time back: cost and autonomy. First of all, Asimo wasn't autonomous, meaning it really couldn't do anything useful on its own. It had to be scripted to follow very specific movements that, when put together, looked impressive, but in reality it was basically just a modern-day mechanical Turk, a machine that appeared to be functioning autonomously, but in reality had a human secretly controlling it the whole time. Besides not being autonomous, Asimo was expensive. Since humanoid robots were brand new at the time, every part had to be custom-made. New parts had to be invented. Smart people had to spend time designing, building, assembling, and programming these things. And that meant lots of time. And time
is money, friend.
What that meant for Asimo was a $2.5 million price tag for something that really couldn't do anything valuable or useful on its own. Sure, Asimo was impressive in demonstrations, but those demonstrations didn't transfer over to the real world. So the dream seemed dead. Asimo, the robot that was once designed to be a home helper for the elderly, was now sentenced to servitude in Disneyland's Autopia. Where was my robot that could take my trash out or wash my dishes or fold my laundry? Well, while Honda was busy discontinuing Asimo, companies like Boston Dynamics were quietly working in the background, making progress, leading to today. 2026. Figaro 3, Optimus Gen 3, a mass-produced Atlas are all being released. Robot roller skates, a humanoid proto-clone, self-driving cars, they're all here. So what changed? How did we get from this to this? The lesson that Asimo taught us was that for a robot to be adopted, it needed to be autonomous and relatively cheap. And 2026 seems to be the year where these developers have gotten close enough to both of those goals for major companies to start investing. So imagine now that you own a warehouse and you're considering buying robots to automate it. What would be important to you? What would you care about in the robots you buy? First, you would probably want them to function on their own. So, autonomy. There are two major upgrades that have brought autonomy in robots closer than ever: foundation models and synthetic data. Foundation models are like the robot's operating system. They come filled with tons of data that the robot can use to understand its surroundings and to perform basic tasks. LLMs like ChatGPT also use their own version of foundation models with data collected from the internet. But those are limited to the computer screen, and robots need to interact with the real physical world. So there's a bit of a challenge. The most popular current example of a foundation model is NVIDIA's Groot. Groot, or generalist robot technology, can be loaded up onto robots, and then they have the data to understand the things that they're looking at and how to interact with them. And the more time robots spend practicing with Groot, the more they'll improve, because data is continuously collected and shared within the foundation model between the robots using it. The other major step towards autonomy is synthetic data. Synthetic data is basically just data that is generated in simulation rather than being collected in the real world. Imagine the robot's job was to pick up car parts and attach them to a car frame. To do that, you would need to train the robot to identify the parts in the frame and teach it how to actually handle those parts. Traditionally, this was done through teleoperation. You would demonstrate the movements you wanted the robot to perform, and it would copy you one-to-one. But this process was slow because the robot could only learn when people were teaching it, so a maximum of 24 hours a day. To fix that, developers introduced simulation. The idea is you create a digital copy of your robot, put it into a virtual world, and then let it practice the motion you want until it gets it right. And there's a lot of steps to simulation that we won't get into today, but the main idea is simulation allows robots to learn at a geometric rate.
Skynet begins to learn at a geometric rate.
If you can create 100 clones of the robot and then let them practice at the same time, they will learn 100 times faster. That's how NVIDIA was able to simulate a year of training in just 50 minutes. Okay, so you own this factory, and clearly these robots are smart enough to do the things that you want now. Obviously, there's still ways to go, but the improvements are clear. But what about the cost? It doesn't make sense to buy an advanced humanoid robot for $1 million if you can get a human to do the same job at a 20th of the price. Well, two factors have brought robot costs way down. Hardware is becoming more standardized, and manufacturing is expanding. If you look at modern breakdowns of robot components and their prices, you'll see that the most expensive parts are usually their actuators. Actuators are precise components that allow robots to move and rotate their bodies. And humanoid robots specifically need a lot of them. These actuators used to have to be custom built for every robot. But now, since the scale of these robots is increasing, robotics companies are often able to develop them in-house, which means they can be produced for much cheaper. Tesla is doing the same with their chips, building them themselves. And as robotics continue to improve, other companies will probably start doing the same. This is how companies like Unitree have been able to bring costs for their base robots down to only $13,000, and they'll probably go lower too with time. So now these robots are cheaper and more capable than ever. That's given major investors enough confidence to start going all in on robotics this year. Tesla is spending $20 billion on robotics and AI this year to expand their training and manufacturing pipelines. Agility has built their RoboFab, a humanoid robot factory, with the capacity to one day build tens of thousands of these robots every year. Figure AI, another robotics company, has raised $1 billion to scale their robots. Besides investments, robot companies are also partnering with companies like GXO, Schaeffler, Toyota, and BMW to run trials in real work environments. And in pretty much all of these cases, the robots being tested have demonstrated measurable added value. But for them to really become widespread, humanoid robots need to be better than the robotic arms that we've been using for decades, or the Roomba-like robots that are used in Amazon warehouses. I was surprised to learn that only about 20% of warehouses in America have adopted any form of automation as of September 2024. It turns out, paying off the high cost of automation could take longer than the lease on the building that's being automated. I mean, it makes sense that a warehouse wouldn't want to spend $1 million on a robot arm if they couldn't pay it off in time. But humanoids have an advantage here, because one of their biggest strengths is that they can be dropped in anywhere. And when the lease runs out, you just pack them up and toss them in a van and take them with you. There are definitely a ton of other things that have improved in robotics over the past 10 years that have got us to today. But you might still be saying, it's not enough. I mean, historically, look at tech companies and they have a pretty extensive reputation for exaggerating what their products can do. And it's fair to be skeptical of, if these robots are worth it in your warehouse. But my recommendation is to just look at it objectively. If you have a robot and it does a similar job to a human, maybe 80% as efficiently, but it costs a small fraction of the price in the long term, companies are going to start buying them. If you look at some of these charts, the average wage for a laborer, like a warehouse or factory laborer in the United States, is around $37,000 a year. And the chart that we looked at earlier suggests that humanoid robots, most of them cost around 60 grand to build right now. So as the scale of production increases, the price of these robots will probably continue to drop. And all of a sudden, you're talking about breaking even on these robots in less than 2 years. Besides cost, though, people are skeptical about robot intelligence. I mean, foundation models like NVIDIA's Groot and synthetic data are improving, but they're still not perfect. So Now you've seen some of the improvements that these robots have had over the past decade, and you see some of the places where these robots are still falling short. But if I'm right, we are at the tipping point of robotics. And if that's true, what's next? Imagine you're that warehouse owner again, deciding if you want to automate your business. You've seen that robots are getting smarter and cheaper. Companies are even building factories to mass produce them. So it makes sense for you to buy in. And lucky for you, you're in the right business. Logistics and manufacturing are where these things will be used first. Safe, controlled environments where improvements are obvious and errors are easy to track. But as they get better, smarter, and safer, they'll start moving over to other workplaces too. Imagine walking into a restaurant where a robot is cooking your food in the back, or a robot stocking shelves overnight at a grocery store. Maybe one day you'll come home and your robot has already done every one of your chores. Getting there takes time, but it's pretty safe to say that robotics are now entering the phase where they can become a scalable commercial product. Technology tipping points usually follow a pattern. The breakthrough isn't the end state. It's the start of a long phase where complementary tools grow, robot maintenance businesses, software packages, and so on, before productivity can boom. The long-term goal for companies like Tesla, Agility, and Boston Dynamics is to turn robots into a general-purpose technology, a GPT. Computers were one, smartphones were another, and humanoid robots are probably next. But technologies like this usually come with something known as a deployment lag. A classic example of this is electrification. When electric motors were first invented, factories didn't suddenly become more productive overnight. It took decades for them to redesign their systems around electricity before the real productivity gains appeared. The technology might be ready this year, but it'll take some time for businesses to fully figure out how to use it. So 2026 might be the tipping point. Embodied AI models are becoming better and more accessible. Hardware costs are decreasing. Data generation is scaling with synthetic data, and companies are spending billions on these things. But there are still many challenges ahead. Either way, 2026 marks the first time where multiple competing robots are moving out of the lab and into real workplaces like factories and warehouses. And if that continues, which I think is likely, there's a good chance that historians will look back at this time period and say, this is the point where robots stopped being science fiction and started becoming the reality.